Hello again. Today we're going to be looking at the history of electrical energy. We're going to be looking at some of the circumstances leading up to the invention of electricity and look at some of the reasons that it was so useful during the time that it was invented. As we've learned already, the Industrial Revolution, which occurred over the 18th and 19th centuries, was sparked by the invention of the steam engine. This is a device that could get mechanical energy out of chemical energy. So the device enabled the energy of coal and oil, that is, the energy when they're burned, to be converted into heat energy. The heat energy would heat up water and produce steam, which would then turn a piston or a turbine, leading to mechanical energy. So in all, what a steam engine does is it turns the chemical energy of coal and oil and things like that into mechanical energy or kinetic energy, which is far more useful. Now the thing is, mechanical energy cannot be very easily transported. About the most you can do is spin a disk very fast and then carry that disk somewhere else. It's not a very efficient way of transferring the energy. What people needed was a way of transporting this energy. Of course, when the steam engine was invented, this was impossible. Let's see what it led to. Now, before electricity, all the sources of power were things like coal, gas, and oil, and these were all used in the steam engines of the time. Now, the use of these fuels produced a large amount of pollution and noise. Because the mechanical energy couldn't be easily transported, all the pollution and noise occurred at the site of the factories and at the site of the steam engines, which tended to be right in the middle of the city. So many domestic tasks were still performed by hand because, of course, you didn't want a big old dirty steam engine in your house. Now, the demand for workers to work in the factories and so on, powered by the steam engines, caused a migration of people from the country to the city. And in fact, there are a number of historical dramas that have been written about this period. Overpopulation, poor working conditions, inadequate sanitation around that time, especially in the large cities, for example London, led to the formation of slums with very poor living conditions. Taking a break from London for a moment, we're going to go to Italy. So in 1791, this fellow over here, Luigi Galvani, was studying static electricity. It's a topic of a lot of research during the time. Now, as it happened, he was dissecting a frog in his laboratory. Perhaps he was using the skin of the frog to rub on things and conduct experiments with static electricity, but he was doing his dissection in the laboratory, the same lab in which he studied static electricity, of course. During the dissection, his scalpel became charged with static electricity. So when Galvani's scalpel touched one of the frog's legs that he had dissected, the leg twitched, which of course amazed Galvani. The leg was supposed to be dead, right? So he found that he could also cause the leg to twitch by bringing two different pieces of metal into contact with it. He could use copper and iron, for example, and by poking them into the leg, he could cause it to twitch. So he called his discovery animal electricity, and he believed that he was figuring out a way to get the life still left in the leg to cause it to twitch. He thought that this animal electricity was indistinguishable from the animal itself. It's something unique to the animal and confined within it. Not everyone agreed with his views though. Later, this scientist, Alessandro Volta, who later became Count Alessandro Volta, invented a chemical battery based on Galvani's discovery. And the thing about this battery is, it was built out of only inanimate materials. It didn't contain any part of a living thing in it. The Voltaic Pile contained only metal and cloth. So it proved that Galvani's animal electricity, so he called it, wasn't actually part of the animal. It came from the metals that he was using to poke the frog's legs with. The Voltaic Pile looked something like this. It consisted of a stack of copper and zinc discs separated by moist cloth. We can also use copper and brass because brass is an alloy of zinc and copper. So the cloth, which we can see represented by white in the diagram, is moistened by something like acid, and it replaced the frog's legs. Now, acid is able to conduct electricity, but what Volta failed to realize is that the acid is actually an intrinsic part of this sort of battery. And without the acid, even if there was electrical contact between the sets of discs, there would be no electric current. Anyway, Volta was able to show that the electricity produced by the battery could travel even long distances along metal wires. So it meant that we had now produced a way to transfer the chemical energy inside the acid and the metal into electrical energy. Soon after that, electrical energy became the subject of a lot of research and study. Which leads us to 1831, when this fellow, Michael Faraday, discovered the interesting connection between electricity and magnetism. And so, in fact, he was able to discover the principles of electromagnetic induction. The principle of electromagnetic induction we'll be getting onto next year at some point. For now, all you need to know is that electromagnetic induction allows the conversion of mechanical energy into electrical energy. That means that if we have a large source of kinetic energy, we can produce a large amount of electrical energy. Can you see where this is heading yet? So the fact that we could do this led to the invention of electric generators, which would convert large amounts of kinetic energy into large amounts of electrical energy, which could then be distributed. Now remember, 1831 was still during the Industrial Revolution, where steam engines, which produced very large amounts of kinetic energy, were quite popular. And now you can see why electricity was so great when it was invented. So mechanical energy from steam engines could be used to produce electricity in large quantities. So it means that as long as you fuel the generator with coal or oil or gas, we can produce fast-moving steam that has a lot of kinetic energy, and that kinetic energy can be converted into electricity. The electricity, of course, can be transported very long distances, which means that we no longer needed to burn a huge amount of fossil fuel on the same site as the steam engine. So by 1900s, electricity generators were being used in many Western cities. It was during the 1890s that long-distance electricity transmission became possible with the advent of alternating current, or AC power. Once we had electricity being able to be sent everywhere, we started getting domestic electric appliances, that is, appliances using electricity that could be used in the house. Electricity was used for heating, lighting, cooking, refrigeration, and so on, which we of course now know today. The generators could be located far outside the cities that they were needed in, whereas if we were still using steam engines, we would need to have the steam engine right where we needed the energy. Because we could locate the generators outside the cities became less polluted and nicer places to live in than during the height of the Industrial Revolution. Now, the use of electricity has paved towards the way of the electronic society of today. Remember, electronics use electricity in order to do things like manipulate numbers. Now, most electricity in the world is produced by power stations that use fossil fuels or nuclear fuels in order to get energy. It takes the energy out of the fossil fuels or the nuclear fuels, converts it to kinetic energy, and then finally converts that kinetic energy into electrical energy. So some generators, instead of using these sorts of fuel, will use things like water power, wind power, or solar power, which is a nice little throwback to our earlier forms of power. Alright, so that's the end of the theory. We've learned a little bit about the history of electricity, how it was invented and how it gained popularity during the Industrial Revolution. Let's go on to some questions to check your knowledge.